Hi there and welcome to another short web snippet brought to you by the guys here at Innova Systems. My name's Matthew and this time we're going to have a quick look at setting up the mesh for sheet metal components in SolidWorks Simulation. Okay, so what we've got here is a nice simple and straightforward sheet metal component, and what we're going to have a go at doing is setting up the mesh so that we could run an FEA analysis of this component. Hopefully, first of all, you'll be aware that SolidWorks by default assumes that because we've generated our geometry using the sheet metal tools, that we want to generate our mesh using the surface mesh tool. So if I just right click on the mesh here and have a look at that, you'll see that what we get is a two-dimensional mesh, and what SolidWorks is going to do is extrapolate the information that it generates from this two-dimensional mesh into 3D results. So it's going to tell us based on the thickness of that material, which SolidWorks has picked out automatically for us, it's going to work out the stress values on the top and bottom surfaces with respect to the geometry that we've got on the screen now, and it's going to extrapolate out to the extreme top and bottom surfaces of our original model. And that's absolutely fine. That's something that we may want to use straight away. Obviously I'd refine this mesh a bit further, but for now that's absolutely fine. So let's have a look at another strategy. So what you'll see I've got here is exactly the same model, but what I've done is removed those sheet metal features, so we've just got one solid body. And the difference that this is going to make is that now when I go to generate a new study, I'm just going to call this one 2, SolidWorks assumes that this one is a solid body, so we don't get all of that automatic information pulled through. So now we have to do it ourselves. If I right click on the solid body component, we can ask SolidWorks to treat the component as a shell or a shell mesh by selecting some faces. So if I come in here, I know that my component is 2 millimeters thick, and then I'm just going to go around and grab all of the outer faces of this component. Like so. And finally I'm just going to tell SolidWorks to offset to the center of the surface, and this aids in that extrapolation process. What we ideally want is for SolidWorks to calculate the results on the midplane and then extrapolate to the top and bottom surfaces. Now if we have that midplane, then the distance between where we're actually doing the calculation and the top and bottom surfaces, which is where we're going to try and present the results, is kept to a minimum, hence the error is reduced. So here we're just going to select this option here to drop that calculation plane down to the mid surface from where we are. And SolidWorks is going to do that by using the thickness value that we've already placed in. And now all I need to do is ask SolidWorks to generate that mesh again, and it'll go and do exactly the same as we had before. So that's a different way around generating a shell mesh if SolidWorks hasn't done it for us. Now sometimes we do get into a situation where perhaps extra detail or a need for very, very precise accuracy dictates that we need to use a solid mesh. Now this obviously isn't usually recommended because calculating very, very thin components using solid mesh means that you need a lot of elements. Ideally we want to have 2 mesh elements spanning through the thickness of the material, and hence for sheet metal components this can give us a large number of elements and hence take a very, very long time to solve. But sometimes we do end up in a situation where it is required and we do need to be analysing the stresses through the thickness of the material. So here's one handy tip just to quickly get around that so that you're not having to generate a really, really fine mesh. So coming back to our original model, you'll see what I've done is generated a mid-surface plane, and that's really, really easy to do. If I come up to Insert, Surface, Mid-Surface, I can ask SolidWorks to find all of the face pairs, and then just hitting OK we'll get this mid-plane surface. And that is one continuous surface that represents the very mid-plane of the thickness throughout the model. Then what I'm going to do is come up to Insert again, Features, and then Split. You'll see I've already generated this feature here, and use that split feature alongside the plane that we just created to actually split the component into 2. So now you'll see we've got an outer and an inner component. Now when I bring that back through into SolidWorks Simulation, now you'll see that we've got 2 solid bodies and 1 surface body, which is our midplane. I'm going to right click on the surface body and exclude it from the analysis because it's irrelevant now. We've got our 2 bodies. And now all we need to do is make sure that we're telling SolidWorks that these two components are bonded together. So they'll be treated as the same component. But because we've got that split between them, when we ask SolidWorks to generate our mesh, we're forcing SolidWorks to generate mesh elements along that split edge. So now we have to have two elements throughout that thickness. So we can refine our mesh and make sure that we're getting enough elements through the thickness and getting a good through thickness stress result without actually having to bring our mesh size down to half the thickness, because as you can imagine, that's going to make our mesh elements really small. So this is one way that we can start to converge on results without jumping straight in at an incredibly fine mesh level. Okay, that's just a few quick tips for setting up your mesh on sheet metal components in SolidWorks Simulation. As always, if you want to get in touch with us here at Innova Systems, you can do so by dropping by our website, which is www.innova-systems.co.uk. You can send us an email at support@innova-systems.co.uk, or you can call us on the number that you see on your screen now.